see some headlines from chapter 2, and then we will apply them in our side by side. But second chapter from the book that we are following. I think I have shared the book with you, your classroom, in the WhatsApp group. So that's the chapter 2, which is about the understanding your data, because the data can have a different varieties. Data can be numbers, and data can be English language or any other language. Data can be time series data. Time series data means where where the time is used as for recording the observations. For example, stock exchange, for example, daily temperature. Today it is 38 degree, yesterday it was 34 degree, and the day before yesterday it was even below this. So time series data. So if it is time series data, the approaches and techniques will be different. And if it is spatial data. Spatial data is the one which works about the location or some space. For example, with the GIS images, satellite images in the GIS analysis, so we can say how many houses. Book is not shared yet. Okay, I will. So we can, for example, in the Karachi survey for the census, one of our professor did this research that with the help of satellite images of Karachi, they estimated the rough population, estimated the population in each area. But because the population density is different in different areas in Karachi, it was a rough estimate, a quite rough estimate. So some of the analysis where you require a space or location, that is called spatial analysis. And the one more analysis is called spatio-temporal analysis. Spatio-temporal means where the location and time is important. For example, in medical science, if somebody have a tumor, the tumor do not stay at the same place. It varies. It with the passage of time. With the passage of time, the tumor increases or changes its location. So that is called spatio-temporal modeling or spatio-temporal data. So today we are looking at different types of data. We will see the different types of analysis in later classes. Because in data mining or data science, the most important thing to do is data preparation. Understanding your data and data preparation. Once your data is ready for the modeling or analysis, then you can do it very quickly with the help of softwares. But this understanding of the data and data preparation is mostly still manual work. There is no complete software, is perfect software that can do this step, understanding of the data, and the next step, which is pre-processing of the data. So that's why we have to go through steps one by one. So from the book, I've copied these headlines. Data objects, I can go back. These are the headlines from the book. What is data object? What is attribute types? So data objects are like databases, and in simpler form, we have a data set. Every database is a data set. We will be using data objects. Attributes are the columns of the data set, or there are various different names. We will see one by one. Some of the statistical analysis, like mean, median, mode, you know all of them. And then variance, then covariance. Co means together, variation between two variables is termed as covariance. We will see covariance and correlation. You know, correlation is the strength of relationship between two variables and maybe more than two variables. Eigenvalues. Eigenvalues is a mathematics term from linear algebra, which is used to see from a large number of variables, variables or fields, which of the fields are most important. So if eigenvalue is large, we say the variable is more important, and if eigenvalue is small, close to zero, we say that a specific variable is not much important. So this is very useful technique, method in linear algebra or calculus, and we will use it in this session. Data visualization, the most simple approaches are histogram. Histogram, you know, these are the adjacent bars of a data set of frequency curve. Scatter plot, box plot, quantile plot, quantiles like quartile. So quantiles means to split the data into 4 pieces. So quantile plot, correlation plot. But in chapter 2, I found there's a lot of many more visualization techniques, like, you know, the smiley faces in WhatsApp. So those smiley faces are called Chernoff plots, Chernoff visualization. So we have Chernoff visualization, Chernoff visualization, and more plots in this wagon wheel diagram and so on. I don't know how much I can cover it today, but this chapter has everything. Then we have data similarity / data dissimilarity. You know, for calculating the distance between two objects, distance, how far they are from each other. So this is the same concept. The distance concept is also called dissimilarity between observations or variables. So we can calculate the dissimilarity. Dissimilarity stands for distance, type of distance, and similarity is the reciprocal of distance. If two variables or two objects are similar to each other, there will be a small distance and high similarity. There are in total more than 100 data similarity and dissimilarity measures. Some of them are in data mining, some of them in natural language processing, some are in other fields like economics have a different flavors, and sociology have different variables, different type of dissimilarity measures. Human psychology, if we study human psychology have different measures. So we will only see on maybe maximum 5 to 10 data dissimilarity and similarity measures that we will use in data clustering and regression analysis. So this is the main, but it is very large scope for this session. We might cover or partially of it. So what is data objects? So it is very important to know your data. This is the first thing. If your data is numeric data, then the methods that you have to apply on your data will be different. But if it is categorical data, categories, for example, good, better, best, or gender like male, female, or education level like engineer or doctor or something else. So these are called categorical data. So when we have categorical data, we will have very different way of data analysis. Yes, Dilawar have some question? Dilawar Asad.
अगर आप बुक का नेम वगैरह कुछ शेयर कर दें ताकि मैं आगे इन्फॉर्म कर उसको मज़ीद शेयर कर दूं।
एक बुक जो है वो मैं समझे थे, मैंने आप लोगों के ग्रुप शेयर कर दी है, मैं इसलिए
नहीं कोई मसला नहीं सर, वो अगर आप वो दोबारा नाम उस पर शेयर कर दें या बुक का वो शेयर कर दें कोई टाइटल वगैरह ताकि मैं देख लूं उसे।
बुक है मेरे पास। बुक है और मैं समझ रहा था कि मैंने आप लोगों को शेयर कर दी है और आप लोग जो है वो उसका चैप्टर पढ़ के बैठे हुए हो, काफी ज्यादा अजम्पशन कर लिए थे। तो चलें वापस आ जाओ। लेट मी कनेक्ट and send the book that you can have open on your computer as well. The same book that I said to consider for your study. Yeah, Jiao Han. Good book. I found I found edition 3 is loading. So real world data are typically noisy, enormous in volumes, like maybe gigabytes and petabytes, and may originate from a jumble of heterogeneous sources. So real world data, even if you want to collect your data for the daily temperature, you will find missing observation from the meteorology department. That means even if you want only one observation per day, okay, even there will be missing observations. If you go to stock exchange, you will find missing observations because sometimes there is no trading or some strike, blah blah. In real life, we always have missing observations or noisy observations. So we have to handle these observations first before doing any statistical model or any data mining technique. Enormous volumes, you will find, for example, I think I showed you last time. Thank you. Yeah. CI. If I go to University of California Irvine website, I think I showed you last time as well. And I say view all data sets. See classification 442, regression 137, clustering 117. There is a large collection of data, but most of them are small data sets like 48,000, like 4,000, 37,000. There is a rare chance that you will have a millions of records in the data set. Yeah, 581,000. 581,000. So, but otherwise, you see, they are all small data. If you go to Kaggle, you can find large data sets. Or if somebody is interested in it, okay. Uh, if you go to this type of analysis, University of so every university, most of them have their own databases. You can use those data sets. So you will find a lot. So I did this work. When I was in after this PhD, I did a paper on KDD 99 dataset. So you can see a lot of different data sets that you can. Yeah, this one was how many attacks, how many normal packets, how many total packets. So it is 48, 4.898 million observations. So it's in millions. Still, if you go in the real life, you might have even more bigger values or bigger data sets. So when I come back to this point, enormous in volume, you can have large data sets and may originate from a different sources, heterogeneous sources. So maybe some data is coming from USA, some data coming from India, some data coming from Japan. So you might have data sources, these different data sources from data centers, and you can merge them together to do some analysis. So first, initial question, what are the types of attributes or fields that make up your data? For example, if you have 25 fields, where how many of them are numeric fields, how many of them are categorical fields, which attributes are discrete. For example, uh, family size is a discrete variable, so you cannot use any numeric measurements like mean. For example, if I say family size is 5.5, so it is a bit confusing. So we have to use median in that situation. We cannot use. If you have discrete attributes, discrete variables, you have to use mean or median. Can you calculate the variance, or you have to calculate the quartile deviation, QD? So you have to decide based on what is available. And if you have continuous variables, you can use anything. I mean, mean, median, mode, variance, quartile deviation, blah blah. So these are all basics from your data. What do the data looks like? For example, there may be a lot of many missing observations, maybe missing by systematic error. There are two types of missing observations. One is called missing by random, and second is called missing systematically. For example, missing at random stands for something is missed by at randomly. For example, randomly example might be, I thought that I have shared the book, but actually I did not share the book. So this is missing at random by mistake or by random choice, not a systematic. But if somebody is doing this thing systematically, he said, okay, I will do, but he did not do some work. That means it is systematic error, systematic missing, or systematic pattern. So in data mining, we have to see a lot of many things, like missing observations, like outliers. You know, outliers. Outliers are those observations that are very large or very small than the whole data set. For example, Saeed Anwar was a cricket player, famous player, Pakistani cricket player. He scored 194 runs in, I think, in an ODI or one day international match. And after that, I think nobody made that big score. So that score is an outlier in the cricket history of Pakistan. So if we have something like this, which are outliers, do we have to include the outlier in our analysis, or we should exclude the outlier from the analysis? And one of the best examples in finance in stock markets are 1983 leg day and 2008 recession days and these corona days. So these are the last 40 years. These are events which are very well known in a stock exchange. So we have to think about what is the data, how it looks like, whether there are noisy observations, noise, or there are missing observations or outliers in the data set. We have to do different type of basics, like we have to check mean, median, mode, missing observations. We have to take the summary of the data and visualize the data to see any hidden patterns. So this is all part of the data preparation and understanding of your data. So in any research project or in any market project, you first have to go through these fundamental steps. My colleague Andrew, he used to say that if your data, Andrew is a bioinformatician, senior bioinformatician, and he used to say that if you put your data, that is a 70% of the total job. So if you make your data very well, very proper, that's a 70% of the whole job, and only 30% is left for machine learning or data science, blah blah. So it is so much important. Andrew Worry, yes, Andrew Worry. Okay, so there are different types of variables or attributes. Nominal are the categorical variables like gender, male, female, like level of education, intermediate, matriculate, or PS, undergrad or grade. Binary attributes which have only two possible values, either yes or no, like male and female, like day and night. So these are all types of binary attributes. Ordinal attributes are those attributes which are categorical, but there is order. You know, ordinal comes from order. For example, first position, second position, third position, there is an order. For example, are you satisfied with your present education, or are you satisfied with your present education? For example, 1, 2, 3, 4, 5. 5 is the highest and 1 is the lowest. So this is all ordinal attributes which are categorical. And the last, which is the, so 80% of the data mining, 70 to 80% of the data mining techniques are about numeric attributes. Numeric attributes are very common, like, you know, daily temperature, because today is hot day, or your monthly traveling, how much you travel in a month. So all these are numerical attributes. And most of the analysis and the algorithms are available for numerical attributes. The problem starts when we start using one algorithm for the numeric attributes as well as categorical attributes. That's the point which differentiates a common data analyst or data scientist and a person who have background in this subject. So it's very important. You will see in the market that everybody say he's a data scientist or he's a data mining or data science expert. But this is the starting point where you differentiate from the rest of the other people. Okay. This is verbal, most of it. Attributes, attributes are also the samples in a database or rows of a database. Instances, in database we call instances, or records. Yeah, one more is records, or data points, etc. So there are a lot of many different names. So the most common name is either instances, samples, or records. These are the three which we commonly use. Sometimes we use examples as well, but mostly we use samples, records, or instances. So you have STT databases. So tuple means a row in a database is called a tuple. So you can also say row records or tuples. The columns of the database are called attributes or variables or features. So when you do machine learning, we call them features. When you are doing database, you call it attributes. And when you are doing statistical analysis or statistics related things or data analysis things, this is called variables. So different subjects have different names for the same concept. So we will be using either features or variables. Mostly I don't use attributes, the word attributes. So variables or features. But still, data mining or machine learning is not the answer for every question. You know, multi-level questions. For example, one question having multiple variables. For example, if somebody says, are you satisfied with your life? Somebody asks you, are you satisfied with your life? There may be with respect to financial health, with respect to family relationships, with respect to work relationships and work. So there can be more than 2 or 3 questions in satisfaction with respect to life, satisfaction with life. So these are called multi-level or multi-factor analysis. And there are not many things that we can do in data mining or machine learning when we have to face multi-level analysis. So either maths or statistical analysis have to be done on this type of. Okay. Now I want to show introduction to R and how we will be doing this, how we will be applying R on a data set or more, 2, 3 data sets. So I can, yeah. Basically, R language R language is coming from another language which is called S language. S language was written by Brian Ripley, Professor Dr. Brian, late Professor in Aberdeen University, UK, or Cambridge, sorry, Glasgow University, somewhere in the Scotland side. So he wrote S language in 1980s when my professor was his student, and Professor Dr. Akil Gandhi. So from his S language, it was like a Fortran based something. So new researchers developed the R language. And now R language has so much increased in volume. It has more than 20,000 different packages. There are more than 20,000 different packages in R that you can use in different varieties of fields. So if somebody is from economics or commerce background, he can use different package. If somebody is from physics or chemistry, he can use different package. So that's 10. So this one to say, with 20,000, more than 20,000 different packages, you can do many different things. Except what I am teaching, that will be a generic way, that will be a general analysis. But then you can have more and more different new things as well. So basically, R language is a command line language. You have to go to shell and you can write your code one by one, line by line, or make a script file in a notepad, write your script in a notepad and run on the command line as a bunch. So, but the problem is that when you are working on shell command prompt, then it is not straightforward to do anything. For example, install dot packages, install by pandas. Oh, sorry, we are doing that. So in this black screen, it is not easy to do many things. No, I don't. What we have to do, so your job for today will be to download R in your computer. 4.1.1 is available. You can start working with 4.1.1, or you can download another version. You can install some other version like 3.8 or 3.9 because this is the most recent, so maybe have some issues. Then the problem is we have to use an IDE, RStudio, for example. We use RStudio IDE. RStudio is the interface. For example, in place of writing your commands on the command line, now you can write your commands in IDE, RStudio. There are other IDEs, this is called interfaces. There are other interfaces as well that we can use. One of the famous in the programming community is VS Code. We will not go to VS Code, but this is an option where you can write your code in VS Code and you can join the R code with R code outputs with a Python code output as well, or combine R and Python code with a Java or C code as well. But it will be more and more programming related things, so we will not go to that point. So this is more like professional programmers, but it is very strong. This is an IDE for R, Python, Java, C, any language, most of it. So when we come back to RStudio, you can download RStudio on your machine and you will find different options because we are free guys. So we will search for the free version. There are other options if you like. RStudio, we will be working with RStudio. If you are going towards web application development, data science applications or data mining dashboards, dashboards. So you can do your dashboards using RStudio server, and these are the facilities. But because as a student, you can simply go to RStudio desktop, open source, and download and install it. So this is your things to do for today that will get ready for installation of this. After installation, you will find yourself in this place. So there are 4 main windows which are आपको मेरी आवाज आ रही है?
Yes, sir.
Okay. So there are main 4 windows in the RStudio IDE. IDE is the IDE stands for Interface Design. IDE. Oh. Software. Integrated, yeah, interface, not integrated development environment, IDE. So this is IDE. There are 4 main windows, splits of the window. One pane is the script where you can write your R script, or you can do many other things. This is the console where you can see the output. For example, 2 plus 3 is 5, and sign of 5. So you can calculate anything in this command line. Then, oh, who is this? 1, 2, 3, 4, 5, 6. I don't know. Your seat number or your name is your identification. Anything else is not considered. Not considered. किसी ऐसे को अगर पढ़ना है तो फिर वो बता दे कि भाई वो क्लास ज्वाइन करना चाह रहा है. So, okay. So this is the right hand side window which contains tutorials from here. Environment contains your variables. For example, I say a is equal to 5. I wrote in command line control enter ctrl plus enter. So if you control plus enter to run a line, so you can use control plus enter to run single line. For example, this line, I press control enter, I got a is equal to 5, and you see here in the environment, I can say a is equal to 5 is stored. For example, b is equal to 7, control enter, I see b is equal to 7 is stored in the workspace. In workspace is used in MATLAB, and environment is used in here. And then I say c is equal to a plus b. Then I can say c is equal to 12 is stored in here. So you can save this data. You can save this data. You can open some other data sets, local load workspace, load here R data. So the file names will be .r data. Data file name. So this will be the file name. For example, whatever the name you want to use, .r data. What is a good thing with R data? That it is quickly accessible with RStudio or R. Second thing, it is compressed. For example, if your data is 1 MB file in Excel, it may take less than 100 or 200 kilobytes in R data. So it compresses a data in a very efficient way that you can save your space. If you have large data sets in SQL in your database, then you can store them into R data and save your space and processing time. So this is the way, step by step, history of commands. There are history of the commands. Connections. If you want to connect your RStudio with any data source or any server machine, then you have to use this thing. And this is all about tutorials. If you want to learn, there is a lots of many books available online that you can study. So now the knowledge is at your doorstep in your mobile phone or computer. It's up to you how you want to understand or learn. If you want to learn, there is everything free in R. Not everything, 95% is free in R. Okay, We have 1 minute left. If there is any question, let me know. Okay. So after 1 or 2 or 3 minutes, we will start. We will start with session 2 for today. So basically, we are doing the understanding of the data and data preparation today. Basically, the headlines that I showed here. Some of them will be using some of it and possibilities. Okay, thank you.